Good morning, everyone. Today we're picking up with Lesson 6, Part 2 of Scientific Notation. Our objective is still to use scientific notation to write large and small numbers. Example 5 is asking us to refer to the table at the right and order the countries according to the amount of money visitors spent in the United States from greatest to least. So we've got our countries listed here, starting with Canada, ending with the United Kingdom, and then dollars spent. And dollar spent is listed in scientific notation. So in order to order these from greatest to least, we've got a couple steps we have to take. First of all, for step 1, we're going to look at grouping the numbers by their powers of 10. So we've got Canada and the United Kingdom that have the same power of 10, 10 to the 7th, and then India and Mexico that have 10 to the 6th as their powers of 10. So we've got Canada and the United Kingdom listed first because they both share powers of 10 that are the same, 10 to the 7th, and then they are greater than Mexico and India with their power of 10 being 10 to the 6th. So right now we're saying Canada and the United Kingdom are larger than Mexico and India. Now we look at ordering the decimals. So we know that 1.06 is greater than 1.03. 1.06 was the United Kingdom and 1.03 was Canada. And then we've got Mexico at 7.15 being greater than India at 1.83. So by grouping by powers of 10 and deciding Canada and United Kingdom are larger than Mexico and India, and then ordering the values by their decimals. So let's try this one together. Some of the top U.S. cities visited by overseas travelers are shown in the table. Order the cities according to the number of visitors from least to greatest. So we've got U.S. cities listed here and the number of visitors. So let's do the same thing that we did in the prior example, where we're going to first group by like powers of 10. So we've got Las Vegas and Los Angeles with powers that are 10 to the 6th over Boston and Metro DC area with powers of 10 to the 5th. Now when we put these in order, and remember we're going from least to greatest, we can start taking a look at their decimal values and work ahead a little bit. So with bases of 10 to the 5th, I've got Boston being smaller than Metro DC. So I've got Boston as the smallest at 7.21 times 10 to the 5th, which is less than Metro. I'll say Metro DC at 9.01 times 10 to the 5th, which is smaller than, and between Vegas and Los Angeles, 1.3 is smaller, so that would be next, followed by Los Angeles being the largest. So I've got Las Vegas at 1.3 times 10 to the 6th, and that is smaller than Los Angeles at 2.2 times 10 to the 6th. So let's take a look at a STEM example. If you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8 seconds to walk to the moon. Is it more appropriate to report this time as 1.92 times 10 to the 8 seconds or 6.09 years? Explain your reasoning. And based on what we're looking at, the measure 6.09 years is more appropriate because the number 1.92 times 10 to the 8 seconds is very large, so choosing a larger unit of measure is more meaningful. So we're using years as our unit of measure instead of seconds. That would be like comparing miles to inches. If we're measuring distance from city to city, it would make a whole lot more sense to say 8 miles instead of 354,000 inches or something like that. Okay, let's try another example. In an ocean, the seafloor moved 475 kilometers over 65 million years. Is it more appropriate to report this rate as 7.31 times 10 to the negative 5th kilometers per year or 7.31 centimeters per year? And explain your reasoning. So in this case, we're talking about a very small amount. So it would be more appropriate to use 7.31 centimeters per year. Because it's a very small number, and 7.31 would be much easier to grasp for people rather than 7.31 times 10 to the negative fifth. Okay, your assignment for today is page 55, number 7, 9, and 11. Please make sure to turn it into Canvas once you're finished.